Okay, I'm going to talk you through this matching worksheet. All right, I apologize, I didn't remember to bring one home with me, so I recreated it. Okay, so the part of the issues that we're going to have is keeping track of what we're talking about and when we're talking about it. All right, so when we're talking about a function, the information that we want to know about a function is whether that function is increasing. If it's increasing, then the slopes are positive. And the slopes, meaning specifically the slopes of the tangent line, is called the derivative. So f prime would be positive. The question is it decreasing? Same thing, if my function is decreasing, then the derivative, meaning its slopes, are negative. Okay, is it leveling off? Let's pretend that says, is it leveling off? So by leveling off, I mean doing something like this or like this. So where I level, we have horizontal tangent lines. And if I have a horizontal line, my slope is 0. So a horizontal tangent line has a slope of 0. Okay, I also want to know, are there places where, is there funny business? And by funny business, I mean holes, jumps, blow-ups, cusps, corners, peaks, and vertical tangents. Because if there's funny business, then the derivative won't exist. Okay, and then as far as the derivative goes, I want to know this information. Is it positive? Is it negative? Is it 0? Does it not exist? Okay, and this is what gets hard to keep track of. Okay, now if I'm looking at the graph of a derivative and I want it to be positive, a positive graph, a graph with positive values, lies above the x-axis. Okay, so now the information I'm writing right here is like stuff that we never, ever write on paper. Okay, these are not good justifications, but just so that we can verbally talk about it, if something has positive values, it will lie above the x-axis. If it has negative values, it will lie below the x-axis, if I'm looking at the graph of the derivative. Okay, if it has a value of 0, it will hit the x-axis. If it doesn't exist, well then it doesn't exist. Right? Okay, so going back to here. All right, one of the things that I think I did mention before the bell rang was that I'm looking at y versus, I didn't label this one right, y prime. Okay, so the top 4 are x and y, meaning these are our functions. Okay, these 4. And then these are all labeled y prime, these are our derivatives. And we have to match to see what goes with what. All right, so I'm gonna start with this parabola, or something that looks like a parabola. I don't really know that it's a parabola, I just know that it looks like a parabola. So I can say that my function is decreasing. Okay, the slopes are very negative, and then they get less negative, and then closer to 0. And then they get small positive and bigger positive. Okay, so as far as this function, we're gonna make something called a sign chart. S-I-G-N, sign chart, not trig sign. All right, so, I don't want that. Okay, so my function is gonna go from decreasing to increasing, right? And it changes here. If I run a tangent line through, my pencil is a tangent line, you could see that I have a slope of 0 at the origin, and then my slopes go to positive. So I'm just gonna mark that the value of the derivative is 0 here. All right, so my function goes decreasing to increasing, okay? Decreasing, increasing. The values of the derivative will go from negative to positive, okay? Negative to 0 to positive. So now if you guys think, if you remove yourself from those graphs and I want values to go from negative to 0 to positive, okay, these values, forget about increasing, decreasing on this graph. These are graphs of derivatives. The values are positive because they're above the x-axis, then they're 0, then they're positive again. These values start out because they're below the x-axis right here. They're negative values. This section is above the x-axis, so those are positive values. Then I go back to being below the x-axis, which are more negative values, and then above the x-axis, which are positive values, okay? That's way too much going on. This graph goes from below the x-axis to above the x-axis, so this graph goes from negative to positive. This is our graph, okay? So this one goes with number 7, okay? If I look at number 8, if you guys look at this, my function is increasing the entire way through, okay? At 0, I have, this is why I had such a fit about the way you graphed your cubic functions. Looks like a cubic, right? You see how I level off at the origin. Okay, I have a horizontal tangent there. So the value of the derivative is 0 at x equals 0. My function increases, levels, and then increases some more. F increases, levels at 0, and then increases some more. So the value of the derivative, if a function is increasing, its slopes are positive. Okay, so I need a graph, if I'm going to graph its derivative, that goes from positive to 0 to positive, meaning above the x-axis to hitting the x-axis to above the x-axis. So above to hitting to above. That's this one. That one goes with number 8. Okay. There's a lot going on number 9, so I'm going to come back to it. And by process of elimination, I'm going to look at number 10 first. All right. So if I make another, it's just this little sign chart, a sign graph, whatever you want to call it, is just an x-axis, and I'm going to label key points on the x-axis. I think you guys can see I'm aligning it with the actual graph. So I'm making little marks where I have my horizontal tangents. Okay, we're actually going to call those values where those important things happen, critical points. Okay, so going back to this list that I made, if f prime is 0 or f prime does not exist, we call that a critical point, and I'll give you more notes when I get back. Okay, but the critical points are what we're going to put on our sign charts. All right, so you can see I've got horizontal tangents here, here, and here, so I'm going to mark those on my sign charts. I don't need to know the x-coordinates, I just need to know that they're there. It says critical points, not critical pants, although pants are also critical. Okay, so now when I'm looking at a function, which is what I'm looking at here, these are our functions, I look at whether or not the functions are increasing or decreasing. So I would like for you guys to pause the video and decide, I marked the critical points already, so before then, am I increasing, decreasing, and then between, increasing, decreasing, and all that kind of stuff on the bottom level. Okay, and then you can come back to me when you're done. Okay, so hopefully you guys said that this graph part, this section of the graph is decreasing, and then I start increasing, and then I decrease again, and then I increase again. Okay, these little points that I labeled where I have horizontal tangents, the value of the derivative is 0. Okay, now, if a function is decreasing, my slopes are negative. F prime would be negative, so there I'm negative, there I'm negative. This sign chart is just a really nice way to organize our information. I hope that me talking emphatically with my hand is not making you motion sickness while I'm holding the camera. I apologize. I did not travel with the iPad, so we're going old school. Okay, so, and then when a function is increasing, its slopes, or its derivative, is positive. All right, at this point, when I've got a lot going on a graph like this, sorry, this is what I'm looking at. Okay, so I ignore this for a second. Don't actually cross them out. I want you guys to focus where we need to focus. Our sign charts are super helpful. So I need a graph to go from negative to positive to negative to positive. Meaning, and again, I don't write this down. This is the information I write down. F prime goes from negative to positive to negative to positive. But if a graph is negative, its values will be below the x-axis. And then when a graph is positive, I will find it above the x-axis. So do you guys see how I go below, above, below, above? That's that one. Okay. On this one, I'm going to work backwards, okay, just to show you that I can. These are the derivatives. So if I'm looking at the derivative, before, when I was looking at the function, I was looking at where my function was increasing or decreasing, and then the information about the derivative was whether or not the derivative was positive or negative. but I can go backwards. I can say, oh, the derivative is positive here because it's above the x-axis. Okay, so I'm gonna mark f prime, and it's positive here. And then f prime is below the x-axis on this interval, so f prime is negative. And then I'm above the x-axis on this interval, so f prime is positive. I'm below the x-axis on this interval, so f prime is negative. I'm above the x-axis on this interval, so f prime is positive again. Okay, and then from that information, I can also gain information about the function. When a derivative is positive, a function has to increase. Okay, so I'm going to increase on these intervals. Hang on. Sorry. Okay, when a derivative is negative, a function has to decrease. Okay, so now if I work backwards, I need my function. I'm going to forget about the top line now, and I'm going to focus in on the bottom line since I'm working backwards. And I need my function to go from increasing to decreasing to increasing to decreasing to increasing. Okay, and if I look at that graph, did I copy this down wrong? Oh, you know what? It's just that this piece shouldn't be here. I think I drew too much of it. So let's just start with the decreasing to increasing. So you guys see how I decrease to increase to decrease to increase. Those are the two that go together. Okay, so this one's number 9. Sorry for getting over ambitious and drawing too much graph. Now, just to make a note, when I have a true parabola, not something that looks like a parabola, but when I have a true parabola, its derivative is often linear. Okay, when I have a true cubic function, its derivative is usually a parabola. Okay, and if you guys think about what you guys did when you used limit, definition, and derivative, every time you started with a function that was a parabola, the formula for the derivative was always a linear function. When we took the derivative of y equals x cubed, we found that the derivative was 3x squared, which is a parabolic function. Okay, what does this look like the graph of? Think about it. Okay, it definitely looks like a trig function, right? And it looks like cosine x. And the derivative also looks like a trig function. It's not quite sine x. What is it? It's negative sine x. Okay, so that is how we can do matching.